Hello, so here's part two of my video on finding inverse matrices. And this method that we got to at the end of the last video works for a 3 by 3 or a 4 by 4 or a 5 by 5. What I'd like to do is just take us back and use the one we created just now in earnest, yeah? So let's work our way down. Here we go. So we calculated this inverse matrix just now, and how we're going to use it. Well, we're going to apply that as the inverse matrix. If we want to find what the x vector is, we're going to use the inverse matrix multiplied by the constants vector there, aren't we? So here's our inverse matrix, here's our constants vector. Let's multiply them out. So we just use our standard method here, don't we? If I want to find the upper value here in the solution, well, I take the upper row of the matrix and multiply it by the column of the vector. So what am I going to get? 4 times 10 minus 2 times 32 plus 7 times minus 30. If I do those calculations and add them together, I get plus 126. If I do that for the next row and the columns, I'm going to get 100 plus 252, and if I do it for the bottom row and the columns, I'm going to get, do those calculations, I'm going to get 378. And then of course got to have the determinant, which is out front, 1 over the multiplier of 1 over 126, which is the same as dividing by 126, isn't it? So 126 divided by 126 is 1, and 252 divided by 126 is 2, and 378 divided by 126 is 3, and that's basically our xyz vector. There we go. So x equals 1, y equals 2, and z equals 3, and that's how we use it in practice, just like we did for the 2 by 2. Now there is something we just need to think about, and I want to look at it and graphically so you can understand what happens if the determinant is 0. So we looked at that before with a 2 by 2, so we had 2 lines and the intersection. So what does this mean? Well, this is a 3 by 3 with 3 unknowns. So effectively what we've got here is 3 planes, plane 1, 2 and 3, and what we're doing is finding the intersection. So our solution here, that point in 1, 2, 3 that we worked out, is the intersection of 3 planes. What happens then, we calculated our determinant as 126. What happens if the determinant is 0 in these? Well, again, we've got no single solution. So let's have a look at what we could have. Well, there are some situations where we have more than one solution. Well, the first one here is if I have my 3 planes here are actually, they all meet in one line, so I could have a line solution, or I could have it where actually the 3 planes are actually the same plane, so the whole of the plane is a solution, and both of those would have a determinant of 0. And let's have a look at the final part. What's the other options? Well, there's a couple of others where we have no solutions. So if I've got 3 planes and actually they meet here in 3 separate lines, like in a prism, can you see we've got a prism here? That's got no solutions, has it? Because no point is on all 3 planes. Second one up here is this, where 2 of the planes are parallel and they never meet, and the other plane crosses them. So I've got only 2 lines of intersection here, but no point is on all 3 planes. And the third one here is all 3 planes are parallel to each other and they never meet, so at no point is there a point that's on all 3 planes. So there you go, that's a simple bit of it. That's your final statement. Yeah, let's pick it up from there. There you go, find your determinant, and remember that your determinant must not equal 0, or we haven't got an inverse and we haven't got a single solution. So there you are. Bye.